Good morning. This is, in case you missed the notes on algebraic representations. We're going to go over this. First is our little section called additive and multiplicative relationships. An equation, table, graph, or verbal description can describe the relationship between x and y. Okay, so we can write it as an equation, we can put it in a table, we can graph it, or we can just describe it with words, the relationship between x and y. Now, let me remind you that on a graph, x values are down at the bottom on the horizontal axis, horizontal side to side. Y values are on the vertical axis or go up and down, okay? X values are what's usually called the independent variable, and Y values are usually dependent variable, okay? Independent variable means that this is the number that's going to determine the value of this other number, okay? All right, so first of all, let's look at an additive relationship. If we want our y values, it's going to be our x values plus a certain set number, and I'm just going to represent that set number with the letter A, okay? So for instance, if I have an x value of 0, and let's say that my A in this case is 2, then I'm going to say 0 plus my A, 0 plus 2, gives me a y value of 2. And I can plot that. On this, your scale, I think, is off. This should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So sorry about that, but they gave you a different scale than they should have. Okay, so for instance, additive relationship. 0 plus 2 gives you 2. If I had an x value of 1, again, plus 2 would give me a y value of 3. If I had an x value of 2, well, take that 2 and then plus my a value, which is also 2. 2 plus 2 gives me a y value of 4. An x value of 3. 3 plus my a value, 2. 3 plus 2 gives me a y value of 5. I'm hoping you're seeing how this works now. 4 is my x value. Plus 2 gives me a y value of 6. Okay, so this is represented as a table. So the information is represented here as a table. Here we're representing it as a graph. Okay. So I'm going to take the x and y values and plot them. Remember that x values are side to side or horizontal, and your y values are on the vertical axis or up and down. Okay, so this is 0, 0, 2. All right, I've plotted that one. 1, 3. Plotted that one. 2, 4. 3, 5. 4, 6. Okay, so this graph shows you the same relationship as this table. Okay, if I wanted to, I could keep going on the table and I could keep going on the graph as well. Usually if you draw a little arrow at the end of your line, that means, hey, this could keep going if we wanted it to. Okay, but the bottom line is we take our input value, which is x, add a certain amount to get our y value. That's an additive relationship, okay, because we're adding. We also have what's called a multiplicative relationship, where we take our x value and multiply it by a certain constant, and we get our y value. So in this case, our a is going to be like our multiplier, and I'm going to give you an a of 25. Okay? The way we write this is a times x. If I give you an x of 0, 0 times 25 is 0. Okay, I'm going to go ahead and plot that point. If I give you an x of 1, 1 times 25 gives me a y value of 25. So 1 and 25. If I have an x value of 2, then 2 times 25 gives me a y value of 50. If I have an x value of 3, 3 times 25 gives me a y value of 75. Okay. If I have an x value of 4, 4 times 25 gives me a y value of 100. And I could keep going. So I'm going to go ahead and draw my arrow like this, meaning that I could add to the table, I could add to the graph. But this table represents the same information as this graph. Okay? All right, and this is a multiplicative relationship because we're taking our input values, our x values, and we're multiplying by a set number. Here, we were taking our input values, our x values, and we were adding a set number, okay? All right, let's go down to the bottom section. All right, so this section is independent and dependent quantities. Independent quantities, first of all, those are your x values. Okay, or input values. Okay, they can be some sort of measured quantity like time, something like that. They can represent some sort of constant. All right, but the big thing is independent quantities. I'm going to put this up here. Determine the value of y. Remember, y are your dependent values. Okay, dependent quantities. Those are your y values. Those are your output values, okay? Like if I input a certain x, I'm going to get out a certain y. So my inputs are x's, my outputs are y's. And it depends on x. Okay. All right, so we're going to look at the only thing that we're given down here is a verbal description. The cost of a snow cone is $150. What is the total cost, C, of S number of snow cones? Okay, so remember, way up here, we said that we can represent a situation with an equation, we can represent it with a table, with a graph, or with a verbal description. Those 4 items. Well, we have 1, 2, 3, 4, all of those items. And the only thing that they gave us was the verbal description. So we're going to look at our 2 variables, okay? And we're going to do a little thinking. And I'm thinking, you know what? Okay, they've told me that 1 snow cone costs $1.50. So the total cost is my y, okay? My cost is dependent on how many $1.50 snow cones I buy, okay? So, and if we were going to say y instead of cost and x instead of snow cones, it would look like this. Okay? Why are they all of a sudden changing variables? They're just using variables that better describe what's going on in this particular situation. So they used C for cost instead of Y because it's more descriptive as to what's going on. They use S here instead of X because, again, it's just more descriptive of what they've got. S represents snow cones. But the bottom line is I took this verbal description and I made this equation. And this is a multiplicative relationship. All right. I can then, I think I'm going to hop over here and do the table. If I buy 0 snow cones, 0 times 150, I am spending $0. So number of snow cones, and over here, dollars. If I buy 1 snow cone, it's $1.50. If I buy 2 snow cones, it's $1.50 times 2, that's $3. Okay. I can do 3 and 4 and 5 and 6. Let's say I buy 4 snow cones. 4 times $1.50, I've spent $6. What if I buy 10 snow cones? 150 times 10 is $15. Notice I didn't necessarily feel like I had to go from 1 to 2 to 3 to 4, although I could have. But, you know, if I buy 1, it's $1.50. If I buy 2, it's $3. If I buy 4, it's $6. If I buy 10, it's $15. But all of this is going to show me the same relationship. If I buy no snow cones, then I'm spending no money. If I buy 1 snow cone, I'm spending $1.50. 2 snow cones, I'm spending $3. 4 snow cones, I'm spending $6. 10 snow cones, I'm spending $15. Okay? And all of the other X's that I could have done that I skipped still fall along this line somewhere. Okay? So bottom line is I can represent a situation like buying snow cones for $1.50. I can represent it verbally. I can represent it as an equation. I can represent it as a table. I can represent it as a graph. And it's all telling me the same information in different ways. Okay? Down here, this is my number of snow cones. Over here, this is the money that I am spending. Remember, your X values go on the horizontal or side to side. Your Y values go on the vertical or the up and down.